Hello, my name is Humair Ahmed and I'm a Network Solutions Consultant at Dell. In this video, I'm going to demo Bare Metal Provisioning 3.0, which is part of Dell's Open Automation framework. Open Automation provides a solution for network provisioning that extends far beyond the basic requirements of network device configuration. BMP allows a switch to be plugged into a network and automatically download a boot image and configuration file from a file server. New in BMP 3.0, the switch is also able to download a script file for automated pre-config and post-config validation. Scripting languages currently supported include Tcl, Expect, and Z-Shell. Bare Metal Provisioning 3.0 allows you to automate your network, prevent errors, simplify troubleshooting, simplify and decrease deployment time, decrease downtime, and decrease IT management costs. Today's demo will be based on the Bare Metal Provisioning 3.0 Automating the Network white paper that you can find on Dell's website. See the link in the description section of this video. Let's jump to the white paper and the specific use case we'll be demoing today. This white paper has all the information you need to get going with BMP 3.0. It even has an appendix that steps through installing a DHCP server and file server, which are requirements for BMP. This white paper discusses 3 use cases. Use case 1, it checks for the latest FTOS image and downloads and applies a configuration file. Use case 2, it checks for the latest FTOS image and downloads and runs a script file for automated prerequisite checks, and if prerequisites are met, it applies a configuration. This configuration is applied entirely within the script. Use case 3, it checks for the latest FTOS image and downloads and runs a script file for automated prerequisite checks, and if prerequisites are met, it downloads and applies the full configuration file. Lastly, it downloads and runs a post-configuration script file to confirm successful configuration and status. Now, I mentioned latest FTOS image here. As long as the FTOS version on the file server is different than the FTOS version on the switch, BMP will download and install the FTOS image from the file server. In most cases, you'll likely have the latest FTOS image on this file server, but I just wanted to make this point of distinction here. I'm going to demonstrate the most complex use case 3, so let's go ahead and jump to that. Before I get into this, let me display my network diagram. For easy reference, I've set the network diagram as the background for my desktop. This highlighted Dell S4810 switch is a switch I'll configure using BMP. This network was set up specifically for the BMP demo, however, in a real-life scenario, this may be part of a much larger spine leaf architecture. As you can see, we have BGP up to the ISP, OSPF, and VLT on the downstream switches. We also have a DHCP server and FTP server on the top left here. Let me talk about the DHCP server for a minute. When the switch boots up in BMP mode, all ports including management ports are placed in L3 mode in a no-shut state. What's happening here is that the switch is acting as a DHCP client on these ports for a specified period of time. This allows the switch time to send out a DHCP discover on all up interfaces in order to obtain its IP address, boot image file, and configure script file. In our case, we only have the management port connected to the management network. However, if we had more connections, a DHCP request would be sent out on all ports. Next, the port that receives the first DHCP offer with a valid payload that contains the FTOS image info and configure script file path info will remain up and require the respective IP address. The other ports would be shut down. Finally, the respective FTOS image would be downloaded and installed if it's different than what's already on the switch, and the respective configure script file would also be downloaded and applied. Let me show you the DHCP configuration file. So here I have a CentOS Linux machine, or a CentOS Linux server, and I have a DHCP server installed on that, and this is the DHCP configuration file for that DHCP server. As you can see here, This is the range of IP addresses the DHCP server will use for DHCP clients making DHCP requests. If I scroll down, you can see a host section here. I only have one switch using BMP, so I only have one host section. If I had two switches using BMP, I would have two host sections, and if I had three switches using BMP, I would have three host sections with the respective fields updated. What it's saying here is any device that makes a DHCP request and that device has this MAC address, give it this IP address. So this MAC address is the MAC address of our switch, so our switch will get this IP address. You can also see here the full path of the FTOS image and the full path of the pre-configuration script file, which is an expect file. Let me go ahead and jump back to the white paper now. So in use case 3, it checks for the latest FTOS image and downloads and runs a script file for automated prerequisite checks. And if prerequisites are met, it downloads and applies the full configuration file. Lastly, it downloads and runs a post-configuration script file to confirm successful configuration and status. In this use case, we have 3 files involved. This first file is the pre-configuration script. It's actually an expect script that employs LLDP to confirm that each port is connected to the correct switch and correct port. If the prerequisite LLDP checks pass, the switch will download a complete configuration file and post-configuration script file. Once the configuration file is downloaded and applied, a command in the config file runs the post-configuration script. This is the post-configuration script. The post-configuration script will test for BGP and OSPF connectivity and confirm neighbors are in the correct state. Additionally, it will use the ping command to confirm connectivity is good through the downstream switch's VLT. Upon failure or success, a log file used for tracking the progress will be uploaded to a FTP server for the engineer to review. Let's go ahead and jump to the S4810 switch. The latest FTOS image for S4810 has its default boot mode set to BMP, but I'm going to check that anyway here just in case. And you can see here it is set to BMP mode. If I wanted to, I could change the boot mode to normal. You may want to do this in cases where you initially use BMP to initially configure the switch and then you make some configuration changes later. You may not want those changes to be overridden in case the switch reloads and again uses BMP, so you can set it to normal reload here. I'm not going to do that because I want to use BMP. Another option you can do is you can disable the downloading of the configuration or script file. So you can still use BMP, but just download the part where it disable the part where it downloads the configuration or script file by using this command and selecting disable. Again, I'm not going to do that here because I actually want to use BMP and I want it to download and run the pre-configuration script file. So I'll exit out of here and I'll go ahead and reload the switch. So the switch is now reloading, and one of the first things we should see is the DHCP discover and DHCP request being sent out on the management interface. Okay, you can see here FTOS is starting. FTOS is starting to load. You can see here it actually states that bare metal provisioning will be used. Other than this message, so far nothing seems out of the ordinary. So I'm gonna press enter a few times here just so we can clearly see when the BMP process starts. I've noticed the DHCP process starts usually after this message, so it should be starting any second now. And there it goes. So you can see the DHCP discover message, the DHCP offer, the DHCP request sent out on management interface 00, and you can see the management interface acquires the IP address of 10.11.129.215 as we expected. You can also see the full path of the FTOS image here and the full path of the pre-configuration script file here. So you can see here it downloaded the pre-configuration script file and it's now starting to execute that. The first thing it does is start configuring the LLDP protocol. Remember, the pre-configuration script file uses LLDP to check that it's connected to the right switch and to the right port. So the first thing it does here is configure LLDP. You can actually see all the output on the terminal, which is pretty cool. So you can see here LLDP is finished being configured, and now it's configuring the interfaces. It's basically just bringing up these interfaces 10 gig 013, 10 gig 01, and 10 or 40 gig 060 because LLDP uses these interfaces to check its neighbors. So it already brought up 10 gig 013 and now it's bringing up 40 gig 060. And it just has 10 gig 01 left to go. Okay, there's 10 gig 01. Here I paused 10 seconds before checking connectivity with LLDP. I just want to make sure all the neighbors have enough time to come up. And here you can see it starts checking the connectivity with LLDP. The first interface it checks is 10 gig 013 is connected to 10 gig 013 and is connected to the right switch S4810-2. You can see that here it's 10 gig 013 connected to 10 gig 013 on S4810-2. It also checks 40 gig 060 that's connected to Z9001, and you can see that's the case here as well. And it also checks 10 gig 01 which is connected to S4810-3, which you can see is the case here. 10 gig 01 connected to S4810.3. So because of that, the prerequisite check is complete and it passes, and you can see that here. Prerequisite check complete, requirements pass, and configuration will now be applied. And you can see it's downloading the startup config and post config script. And then it applies the configuration successfully, and it starts executing the post configuration script file. You can also see here I uploaded the pre-configuration script log file to the FTP server. And here I'm just waiting 30 seconds because I want to make sure the network is converged before I start checking for BGP and OSPF neighbors. Now you can see the first thing I do is check for the BGP neighbors. You can see I'm executing the post config script here. It checks the BGP neighbors first. Looks like that was okay, so it checked the OSPF neighbors. So OSPF neighbor is learned and the OSPF neighbor is in full state, and that's this switch here. So there's two OSPF neighbors, and here's the second one. This one's also learned and this one's also in full state. That's this connection here. So you can see OSPF neighbor check passed. So now it's checking communication through downstream VLT. And it does this with ping, as you can see here. And the ping was successful, so the communication through the downstream VLT is a success, and the VLT communication check passed. In consequence, the post-configuration check also passed. And you can see here, just like in what I did with the pre-configuration script, for the post-configuration script I also created a log file, and I'm uploading that now to the FTP server so the engineer can see what all the results were. And as you can see, we ran into no problem, so everything was successful and the log files got uploaded to the FTP server. And that's the end of this BMP 3.0 demo. As you can see, it's a very powerful and extremely useful tool for network automation and conditional configuration. I hope you found this demo useful, and don't forget to check out the BMP 3.0 Automating the Network white paper.